So NAD actually acts like a fuel to drive many of the repair processes in our cells. We've got an army of DNA repair enzymes, and we've got an army of proteins called sirtuins that are monitoring cellular health and switching on things that are protective. All of these functions in our cell require NAD as a fuel to actually drive this repair. And this is a really fundamental point that is very misunderstood within the industry, is that we cannot get NAD from our diet. Our cells actually have a pathway in it that makes and recycles all the NAD that we need. And this is called the salvage pathway. NAD is not naturally found at high levels in the blood. NAD needs to be inside of the cells because that is where all of the pathways that it interacts with are found. So yes, an NAD IV will get NAD into the body, but it's not putting it into the right place. It's putting it into the blood. And because NAD is a very large and charged molecule, it does not easily diffuse into our cells.
Welcome to the Gladden Longevity Podcast with Dr. Jeffrey Gladden, where our passion is helping you to become an age hacker. On this show, we want to help you optimize your life energy, longevity, health, and human performance with impactful and actionable information by answering 4 questions. How good can we be? How do we make 100 the new 30? How do we live well beyond 120? And how do we live young for a lifetime? Now, here's today's episode of the Gladden Longevity Podcast.
Welcome, everybody, to the Gladden Longevity Podcast. I'm your host, Dr. Jeffrey Gladden, and today we are tackling the big questions in life. How good can we be? How do we make 100 the new 30? How do we live well beyond 120? How do we live young for a lifetime? And how do we develop a 300-year-old mind? And right at the center of those questions are the hallmarks of aging, which are basically biological processes that accelerate aging as they play with each other. And today I'm going to be talking with Dr. Nichola Conlon, and we've spoken with her before on the podcast. She's has a PhD in biochemistry and is the developer of a product called Nicotinamide. That's Nuchido, Nuchido time. We'll talk a little bit about the origin of that name, but it's a very comprehensive integrated product to boost NAD levels. And I think you're going to find this conversation really fascinating. We talk about NAD, its central role in the hallmarks of aging and anti-aging. We talk about why it declines, how to actually build it. We talk about IV NAD, what that may be good for and what it's not particularly good for. Ways that it might actually be harmful. We'll talk about other products, precursors, etc. It's a really good scientific, comprehensive conversation around NAD and the ways to optimize it. I think you're really going to enjoy this podcast. Welcome, everybody, to the Gladden Longevity Podcast. I'm your host, Dr. Jeffrey Gladden, and today I'm being joined by Dr. Nichola Conlon. It's 2:00 in the afternoon here in Dallas. It's 8 p.m. for her in London or someplace in England. I don't know where you are. Maybe I don't know where you are in England, but you're someplace.
I'm in Newcastle, which
okay.
The furthest north you can get basically in England. So opposite end to London.
Okay. Well, I remember back in, medical school days, there was a Newcastle ale or something that we used to drink. I don't know if it ever came out of Newcastle, but yeah, maybe it did. I don't know.
Quite famous. Newcastle Brown Ale is a very famous.
Right. Yeah, that was it. That was another lifetime ago, but all good. So you're in Newcastle. So, it's really a timely topic always, I think, in the longevity space to be talking about NAD. And, as we sort of expand on the hallmarks of aging, we're now up to about 16 that we're looking at. It's always interesting to see how NAD is kind of at the either close to the center or at the center of optimizing so many of the hallmarks of aging these days, right? It seems like that keeps expanding. I don't know if that's your impression as well, but
yeah, absolutely. And a lot of people always ask me, they always say, why is it out of everything that you could have chose to develop or study or really put your effort and focus into, why did you choose NAD? And one of the main reasons was because throughout all of the time that I have been involved in this space, so, really well over a decade now, NAD is always kept coming back, as you mentioned, is kind of this molecule that seems to be at the center of a lot of, if not all of the hallmarks of aging. There's more and more evidence every day that seems to be appearing that is linking a depletion in NAD with driving the hallmarks of aging, or when you actually replenish NAD with actually improving multiple hallmarks of aging. So I think even now, it's pretty safe to say that it is one of the only molecules that seems to have this really pleiotropic effect, where it's actually impacting multiple different things in one go. And as we know, that's really important because all of the hallmarks of aging are not standalone processes. So although as scientists, we like to kind of group them into these very neat boxes, they're actually all interlinked and they're all influencing one another. And you're never going to get a real impact if you only target one of them. So I think that's what's really interesting about NAD, and certainly the research that continues to come out in this area.
Yeah, I think that's right. I think for the audience, the way that I think it's easy to understand this is that these hallmarks of aging, which are essentially biological processes that sort of degrade with aging, but then also because of their degradation, accelerate the rate of aging, they actually play with each other. And so it's kind of like a tornado almost kind of spinning up, right? So when mitochondria don't work, then you don't have enough ATP, you can't repair your DNA. When DNA is not repaired, your telomeres get short, blah, 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 blah. And it keeps sort of playing off each other. So it becomes a complex, part of the complexity of reversing aging is actually how do you stop a tornado, right? When it's feeding off of itself and feeding off of all the other hallmarks. And so when you have there are a few things that will come in there. NAD is one. A couple other things that come to mind. Spermidine actually has an impact around most of the hallmarks as well. So does fasting, like a 5-day fast mimicking diet, can have an impact on most of the hallmarks of aging. So it's interesting to look at that. And then also when you look at really very novel age reversal strategies like epigenetic reprogramming, like the David Sinclair paper that was published in July of 23, where using a chemical cocktail, they were able to reprogram epigenetic age, kind of mimicking the Yamanaka factors, which is, kind of a cellular reprogramming. One of the things that happens in those more youthful cells is they're able to produce more NAD and recycle more NAD and use more NAD, right? So it's really, it's all linked together. So that being said, one of the things that impressed me about your product, Nuchito Time, was really how well thought it out it was. How well thought out. It's not just, well, take some NMN or some nicotinamide riboside or even some niacin or something and just load that into your system. There's a much more sophisticated thought process there. And maybe you can share that with the audience.
Yeah, absolutely. And I think, as you've just said, when we're looking at anything in biology, especially in aging, it's all very complex and there's never just one thing at play. And what was always interesting to me was how complex the NAD system is in our cells. Often people just think it's just this one molecule, it's important, it declines, let's just top it up and that's the end of it. But actually what we know is that there are multiple processes going on in our cells that are not only using NAD, some of them are recycling it, some of them are actually depleting it, some of them are making it, some of them are recycling. There's all sorts of things going on. And for a long time as scientists, we knew that NAD fundamentally declines as we get older. This is observed in all studies that have been done. It's observed in all species that it's been studied in. So it seems to be a kind of universal decline that we do see with age. But what was never really understood was exactly why it is declining. And usually if something has declined in the body, there is a root cause to the problem. So for a long time, a lot of the focus was not on why it's declined and how we fix the root cause, but on the fact that let's just top NAD levels up in any way that we can, whether that's by using pure NAD in an IV or an injection, or using things like NAD precursors, which are probably the most famous way to boost NAD. Things like NR, nicotinamide riboside, or NMN, which is nicotinamide mononucleotide. And what these molecules are, which have been used for many, many years now, are effectively precursors. So like the raw material that your body uses to make NAD. So the idea behind these products is that if NAD is declined in the body, let's just give the body more of the raw material and hope that it converts it into NAD, which seems very simple. But actually, when you start looking deeper at the science behind NAD, and more importantly, the more recent research that is coming out, which now explains why NAD is declining, these products don't really make as much sense anymore. And to kind of go into that in a little bit more detail, what we now really know is that there are two major root causes of the decline in NAD. The first one is that as we get older, our cells have more damage and they have a higher demand for NAD. So NAD actually acts like a fuel to drive many of the repair processes in our cells. So, we've got an army of DNA repair enzymes, and we've got an army of proteins called sirtuins that are monitoring cellular health and switching on things that are protective. All of these functions in our cell require NAD as a fuel to actually drive this repair. So as we get older, our cells have been around longer, they've got more damage, they've got more inflammation, and ultimately they need more repair. So we start to see an increase in the demand for NAD as we get older. So that's one reason. And then right at the same time, what we see is that our capacity to actually make NAD also declines. And this is a really fundamental point that is very misunderstood within the industry, is that we cannot get NAD from our diet. Our cells actually have a pathway in it that makes and recycles all the NAD that we need. And this is called the salvage pathway. And a key problem that we have when we get older is one of the main enzymes in this salvage pathway declines with age. So we end up in a situation where not only has our demand gone up, but also our cell's ability to make and recycle NAD has also gone down. So you end up with this perfect storm of right when demand's increased, production has reduced, and you get a massive depletion. And what we wanted to do is kind of go, okay, precursors can get you part of the way. We do know that they do get converted into NAD, and we do see a small NAD boost, but you need to actually fix the root cause of the problem if you want a more sustainable method to actually increase NAD levels. And that is exactly what we developed, a product that actually fixes these root causes of the problem.
Yeah, and I think that's right. So it's really a wheel, if you're trying to visualize this, of NAD precursors becoming NAD, being used up and then being recycled through this enzyme. And it's kind of like if your recycling mechanism goes down and your demand goes up, then you can see you're going to end up in a shortage. And there's another piece to this equation that I know Nuchito Time addresses, which is the CD38 portion of this.
Sorry. Yeah, absolutely. So what we know is that CD38 is a very important piece of the puzzle, as you mentioned. And what CD38 is it's a pro-inflammatory enzyme. So essentially, when our inflammatory response is switched on, CD38 is part of the cascade that actually drives the inflammatory response. So every time we have an inflammatory reaction, CD38 is up. Now, what we know is that as we get older, sometimes that inflammatory response is not quite turned off fully. So as we go throughout life, we kind of get small amounts of this inflammation that's still switched on, that builds up in our body, and it acts almost like a smoldering fire. And we know it's incredibly damaging to our cells. And part of this is actually linked to higher CD38 expression. So you will see in an older person that they will have more CD38. And the key link here with NAD is that NAD is actually one of the drivers of CD38. So when CD38 is switched on, it is using up a huge amount of our NAD supplies. So
Yep.
this is the link between the fact that high levels of chronic inflammation as we get older are actually further driving down our NAD supplies. And this is something that actually has a profound impact on our NAD levels. Some of the studies have shown that even by addressing this problem, you can increase NAD levels by 50% just by addressing this wastage problem, shall we say. The other issue is that, and again, something that's not really spoke about much, is when you are boosting NAD, what you need to make sure is that the NAD that you are creating is actually going towards beneficial processes. So you want the NAD to be going to DNA repair enzymes. You want it to go in to be activating the sirtuins. What you absolutely do not want happening is it to be activating CD38. And
Right.
this is a real risk because actually CD38 has what is known as a high affinity for NAD. And essentially what that means is that if NAD is available in the cell, the CD38 enzyme will grab it and use it before the sirtuins can use it, before the DNA repair enzymes can use it.
That's
So
right.
you really do need to make sure that you inhibit CD38 as part of your NAD boosting strategy to make sure the NAD is going to beneficial processes.
Sounds like the Russian economy, right? You got corruption that's basically pulling off the NAD. Then you've got a mechanism for recycling that's declining, right? The manufacturing is declining. Then you've got an increasing need because of ongoing damage. So this is how you set up collapse, right? This would be how you would set up economic collapse. If you're thinking about it in economic terms for the cell, it's almost economic collapse for the cell if NAD is the currency here, right?
It becomes it's a huge mess. And,
Yeah,
one thing is then driving the other thing to become more worse. And you end up in
right,
this vicious cycle, which
right.
is why it is so important to actually address these root causes rather than just trying to ignore all the problems and, chuck in some new currency or chuck in some new raw
Right. Now
material.
you're trying to print money to overcome the problem, right? So
Yeah.
staying on the economic bandwagon here, the interesting thing is if you're just throwing NR or NMN or even niacin into the mix alone, is now you're sort of stacking up bricks in front of a machine that's distracted and things are going haywire anyway, and they can't really make good use of it, right? So one of the things that you've done, I think, both wisely, interestingly, and expertly, is to actually navigate all the elements of the system to where you're providing not only the precursors, but you're also accelerating the recycling at the same time you're blocking the CD38, right? So it becomes a more comprehensive approach. Do you want to talk through a little bit about the studies that you've done that have shown the impact of the synergy and maybe compare that to people that are thinking about IV NAD versus kind of what you're doing? That might be interesting.
Yeah. So, essentially what we're trying to do is make the cell act like it did when it was young and when NAD production was kind of in full swing, because we know in youthful, healthy cells, our body makes and recycles all the NAD it needs in this salvage pathway. Literally, as NAD is used up, it gets broken down into a precursor called nicotinamide. Then this nicotinamide gets scooped straight back up and recycled back into fresh NAD again. And really, it's a very clever way of the cell not relying on a critical molecule from the outside, but it also means that as NAD demand goes up, because NAD is being used and broken down into the precursor, it also means there's more precursor available to then meet the demand in the cell. So it's a very clever system that is set up that does work really well when it's working efficiently. But the key problem here, especially in this pathway, is the rate limiting enzyme NAMPT. And basically, the less NAMPT you have, the less of this recycling process happens. And that is the key enzyme that we see actually decline with age. So I think what you see is if you don't address this problem and you ignore this pathway and you just take NMN or you just take NR, what happens is some of that will go into the system. It will get converted into NAD, but then it's used once and it's essentially broken down. And when it's broken down, it gets converted into one of its precursors, which is nicotinamide. But if this salvage pathway, this enzyme, is not working to recycle this nicotinamide, what we see happen is it actually starts to build up in the cell. And it gets to the point where the cell's like, actually, this is too much. We need to get rid of it. So instead of this precursor being recycled into fresh NAD, the cell actually methylates it and excretes it out of the cell. So again, what you start to see is an increase in another enzyme, which is called NNMT, which is a methylating enzyme, which becomes overexpressed as the cell is struggling to actually get rid of this excess nicotinamide. And this is a problem because it can cause methyl donor depletion, because your methyl group should not be getting used for this process. They should be getting used for much more important things like DNA repair, etc., etc. But they start getting used for this process. And this becomes even more of a problem if you are taking huge amounts of precursors, because suddenly you're getting piles and piles of these precursors in the cell that the cell simply can't deal with. And we do see in some of the human clinical studies that have been done on things like NR and NMN that we see an increase in methyl nicotinamide. So basically, as they increase the dose of the precursor, it increases NAD to a certain point, but then it doesn't matter how much they increase the precursor, the level of NAD plateaus. And that is because the cell can't keep converting it into NAD. And then what you see is the levels of this methyl nicotinamide, this excretory product, keeps going up and up and up and up, which again shows us in clear, solid evidence, this is not theory, this is in a human clinical trial, that the system is becoming overwhelmed and it's starting to have to change other elements of its physiology to deal with this problem to maintain homeostasis. So, that is a key part of why we wanted to design something different. You mentioned very briefly NAD IVs and also probably NAD injections that have become very popular. I mean, a lot of issues around not only the theory behind this, but now some of the clinical evidence coming out, because a lot of people kind of think, well, if NAD is declined, can we give the body pure NAD and will it just go into the cell and get to where it's needed? But what an NAD IV or an injection does is it actually puts NAD into our blood. And NAD is not naturally found at high levels in the blood. NAD needs to be inside of the cells because that is where all of the pathways that it interacts with are found. So what we see and what I've spoke about for a long time now is the fact that, yes, an NAD IV will get NAD into the body, but it's not putting it into the right place. It's putting it into the blood. And because NAD is a very large and charged molecule, it does not easily diffuse into our cells. It struggles to cross the cell membrane, and it certainly needs a very special transporter protein or carrier to get it in. And the majority of our cells simply don't have this pathway to get it in. So what we see is that the NAD is going into a person's blood and it's effectively getting stuck there. Now, there have been 2 clinical trials, which I always find astounding that there are still only 2 clinical trials looking at what happens to the NAD, considering the amount of clinics that are actually doing NAD IVs. And one of the clinical studies showed that the NAD is rapidly degraded into precursors, and then some of these precursors are then taken up, in which case you've got exactly the same problem as just taking an oral precursor. The other paper, more alarmingly, actually showed that not only did IV NAD not increase intracellular NAD, but it triggered an inflammatory reaction. So they saw increased levels of IL interleukins in the bodies. And again, this is worrying because obviously, like, we don't want to take NAD to increase inflammation. But again, looking at this from a purely physiological, theoretical point, NAD is not found in huge levels in the blood. So if you're suddenly putting a huge dose of NAD into the blood, that's usually only found inside the cells. The body's thinking, oh my goodness, what's happened? Has there been a trauma? Has there been something that's caused the cells to release a lot of their contents? and it perceives it as a trauma or a threat. So it initiates an inflammatory reaction to deal with this perceived trauma. So again, I'm really happy to see these studies now coming out, because it supports something that I've kind of been saying theoretically for a long time.
Yeah, it's really interesting. We've never been huge fans of IV NAD. I know there are some particular indications where it seems to be useful, like in acute alcohol withdrawal or opioid withdrawal or situations like that. It can actually have a very salutary effect. And yet I think for the kinds of reasons that people are running into a clinic to get an IV of NAD, I think it's actually counterproductive. Even though it's well intended, it's counterproductive, right? That's why I think understanding the biochemistry the way that you do, and basically architecting a system to elevate intracellular NAD levels the way that you've architected it, becomes really kind of the most intelligent approach. I will say that in our practice, one of the things that we have also found to be helpful is using an ozone sauna to oxidize NADH back to NAD, to change the NAD to NADH ratio in a favorable way. And what we found is that when you take something like Nuchito and you load this into your system, and then you jump in an ozone sauna, oh my gosh, for like the next 3 or 4 days, you can feel like Superman or Wonder Woman, right? I mean, it's just, you really get an amazing boost in NAD. You can feel the ATP that comes off the mitochondria from it. And if you throw in either some D-ribose along with some vitamin B2, some riboflavin, I mean, the next thing you know, it's like, oh my gosh, let's go climb Mount Everest. So
wow, do you know what?
Cool.
I've never heard that, combination before. So that's really interesting. But again, from a scientific standpoint, it makes total sense, because we know that NAD is a redox molecule. So therefore it naturally flips between two states. One of them, it's oxidized form, which you see written as NAD+, and the other, it's a reduced form, NADH. And what we know is that as you get older, the ratio starts to shift more towards NADH. And that's not the direction you want it to be going in. You want to have a higher ratio of NAD+. So that's really interesting to use that in combination with the ozone therapy.
Yeah, it seems to work really well. And we'll take some molecular hydrogen too, actually, just to help kind of mop up, if you will, some of the oxidative stress, the excess oxidative stress you might get from the ozone. So anyway, it's something we've kind of biohacked our way into, just looking at, what can we do to optimize this, since that's a question we're always asking. And that seems to be, quite honestly, the hot ticket. In fact, I'm going to, no pun intended, I think I'm going to do that after this podcast, just because I got in late last night from a flight that was delayed, and I'm feeling like I could use a boost. So, yeah.
Yeah, that sounds like the perfect boost. And we know things like travel, any jet lag, anything like that is also something that depletes NAD. Probably because what we haven't discussed is, not only does NAD naturally decline with age, but lifestyle is also a huge thing that impacts our NAD levels, meaning that in some people it will decline quicker than others. We know people that travel a lot, people that have circadian disruption, we see depleted NAD levels in those people. So yeah, definitely jump in that chamber later and get those levels back up.
Yeah, very cool. So, one of the exciting things that I recently discovered on a call that we had was the fact that you've been able to kind of refine your packaging, if you will. In other words, it used to be that the daily dose was about 6 capsules, and now I think it's down to 3. Do you want to talk about how you did that without compromising the delivery of the product?
Yeah, absolutely. When we first developed the product, our aim was to get a product out to market that actually works and has good science behind it. My PhD back in the day was actually all surrounding bioavailability of active molecules, of drugs, of nutrients. So I was always very particular and very picky about what formats of different ingredients that we used. So, for example, we've spoken a lot about how we target CD38. Now, the way we target CD38 is through an active ingredient called apigenin. We know that apigenin is a very powerful inhibitor of CD38. And so we wanted to include this in our product to actually inhibit it. And unfortunately, there's a lot of hype about using, purified active molecules. So, for example, a lot of the studies on apigenin have used pure apigenin, and they've put it in cell culture. They've shown that it inhibits CD38, which is great. But the reality is that in nature, apigenin doesn't exist in a pure form, which means that you cannot just take pure apigenin orally and it will not have the same effect because it can get damaged in the gut. So, in order to get these active ingredients into the body in stabilized formats, often what you have to do is use plant extracts. So in our formulation, you'll see we use parsley extract, and everyone's always like, why on earth? What is parsley doing in this product? But we know parsley is a very good source of natural apigenin, but that means that you have to use quite a lot of the active ingredients to then actually be able to get the effect. So the result was that when we did our initial clinical trials, the formulation wasn't in capsules. It was something that you just had to have as a powder and drink it, and it had its effect. But it tasted horrendous. So that was never going to be acceptable to consumers. So it had to be encapsulated. And when it was encapsulated, that's when we realized it's 6 capsules. So because we just wanted to get a product out there that worked, we were much more concerned about having the correct doses and having more capsules than trying to cut it and have less capsules and get it out there. So that's why when we initially launched, it was 6 capsules. But since then, because we actually launched back in 2019, believe it or not, ingredient science has really advanced. So some of the ingredients that we use have now become much more purified and extracted, meaning that we can now use lesser amounts of the raw materials to get the same amount of active. So a key difference, just again as an example of something we've changed, is the alpha lipoic acid. So alpha lipoic acid is a key part of the formulation. It's one of the ingredients that helps to switch on the NAMPT enzyme, this salvage pathway enzyme. But a key problem that we always had was the bulk of this raw material that had to be used to actually get the desired efficacy in the cells. And that's because alpha lipoic acid is an incredibly unstable molecule. So you need to use way over to ensure that by the time it's degraded in the body, got through the gut, that there's enough left to have its active role. Now, when we launched, we used the best product or the best format that was available. But since over the years, there actually became new versions available. So, for example, the ALA is now available as an ALA salt. And this actually massively stabilizes the alpha lipoic acid, meaning that you can use a huge amount less to actually get the same active benefit in the body. So through various tweaks like this, we've been able to actually get the formulation down into 3 capsules, which has been, a big advantage for consumers taking it. You can take all 3 capsules in one go with food. And again, because we are very scientifically credible and we want to back everything that we're doing, we actually went and did another full clinical trial to prove that it works just as well as the 6 capsules. So we did a head-to-head clinical trial to actually show that it still has the same benefit as well. And because what we haven't mentioned is we have done a full double-blind, placebo-controlled clinical study on the product, which certainly for supplements is pretty rare, and also in the NAD space is pretty rare because there's a lot of products out there that make a lot of claims but don't actually have any research in humans to back it up.
Yeah, no, it's really great. It's nice to see how you continue to kind of think through the product and find ways to optimize it, not only for efficacy but also just the convenience of taking fewer capsules, right? I mean, there is such a thing as capsule fatigue if people are taking a lot of different supplements. So that's super helpful.
In my goal with Nishido has always been, how do we get this science out to people and make it as user-friendly as possible, whether that's user-friendly in terms of the education and people's understanding of it, or it's user-friendly in terms of the price and cost and, acceptability of people actually being able to take it. Because as well as I, that these things can actually have a real significant impact on people's life. When they improve their cellular health on the inside, it really does have an impact.
Tell me about the name Nuchito. Where did that come from? It sounds like it rhymes with Dorito, but it's...
So Nichola, it's a made up word, but it does have some basis to it in the longevity field, because you will know of the blue zones. So the places in the world where, people seem to live to a great age in relatively good health compared to a lot of countries in the world. And one of the famous blue zones is Okinawa in Japan. And they have a saying, which is Nushi Gasui, which is food is path to long life. So we sort of stole the Nushi bit and put the do on as way. So it loosely kind of has a meaning, but also it's very much made up, because it's very hard to get a name that you can trademark.
Right. That's true. It's hard to get a name you can trademark. Cool. All right. Well, that's good. I didn't realize it was connected to Okinawa. So... good to know.
Yeah,
all right.
There is sense behind it, a little bit anyway.
What's on the drawing board for you guys? Any other things you've got up your sleeve there in terms that you're working on or perfecting this?
I mean, in terms of this product, we are always trying to do further clinical research on it. And a lot of this is based on customer feedback. So more and more we get all sorts of customer feedback, and some things begin to trend where we're hearing it time and time again. And as a scientific company, we don't like to rely on anecdotal data or, customer reviews or quotes. We like to get some solid evidence behind it. So we continue to do smaller studies looking at some of this feedback that we're getting. So like a key one that we've done was a sleep study, because we were getting so many customers saying that they were noticing an improvement to their sleep quality. A lot of our customers have the Oura rings or the Whoop bands. They were noticing improved deep sleep. They were noticing better HRV. So we wanted to do a study to actually measure this. So we did do a 3-month sleep study. Now, granted, it was a questionnaire-based study. It was using something called the Pittsburgh Sleep Quality Analysis. But we did see in all of the 30 participants that 26 of them all saw a significant improvement in sleep quality, and the 4 that didn't just saw nothing change. So that kind of confirms that something is going on here to improve sleep. Again, theoretically, makes perfect sense. NAD is very important in regulating circadian rhythm. So we know that it does have a role in sleep. So from this, we then want to go on and do a further sleep study, which is then using tracking devices to actually really measure this. The other thing we're really interested in is studies surrounding what happens if you improve cellular health on the inside. Does it have visible and noticeable changes to things like skin quality on the outside? And we've done some studies, again, looking at skin quality with special skin analyzer cameras that take pictures of different layers of the skin. They take pictures of the pigmentation, rosacea, redness, and we saw improvements to these parameters as well. The other area that we're really interested in is menopause, because a huge number of the positive feedback from customers that we get is actually perimenopausal and menopausal women that say how much of a real difference it's made to their brain fog and also energy levels. So we're looking to actually set up a study specifically with this category of people to get some data behind that. So that's kind of where we're focused on this product. But in the back end, again, we're actively researching company. I have PhD students. I collaborate with universities. We do a lot of research. A big area of interest for us is senescence, and that's got some really exciting projects that's ongoing that I can't say too much about now, but it's kind of all ticking away in the background. And as you know, senescence and NAD also has a very powerful link between them.
That's right. No, that's exciting. That's very cool. I had not heard about brain fog for perimenopausal women or postmenopausal. Men go through andropause also. I wonder if it would be helpful to them as well. It might.
Yeah, we do have men, that report, especially in that sort of period of life, a significant improvement, especially in things like brain fog, because men do get that as well. It's usually a bit more gradual onset as opposed to women that really notice it, because it's usually quite drastic. And also, if you look at the hormones in women, things like estrogen are, when they drop, they're incredibly pro-inflammatory, because estrogen normally keeps inflammation at bay. So when estrogen suddenly plummets, you get an increase in inflammation, and then you get it's right at the time when NAD is massively declining as well. So you almost get this perfect storm. And so even if you're not addressing the hormones and you're only addressing NAD, you do see a significant improvement.
Nice. Yeah, no, that's really cool. So with the sleep, are you finding that people are taking their Nuchito time at bedtime to get the best results with sleep, or just when they take it?
We recommend to take it in the morning, or as close to the early in the day as you can. Take it with your first meal of the day. And that's just because NAD actually naturally fluctuates throughout the day. It's not a constant. And it's these fluctuating levels of NAD that actually help to regulate switching the circadian cycle on and off. And it's better to... It's not the time at which you take it. It's just the fact that your whole NAD cycle is functioning better. So it has that influence over the circadian rhythm, as opposed to when the whole NAD cycle is all disrupted, it doesn't have that strong influence as it should to switching on and off those circadian transcription factors.
Yeah. Nice. Awesome. Well, lovely to catch up with you again. Really nice progress that you've made. Really congratulations on being able to condense the formulation to 3 capsules. We just got a hold of some of those in the office here, I don't know, a few weeks ago, and people are enjoying having to take fewer capsules. So that's been great. So.
Yeah, no, I bet. No, thanks. It's been really nice to catch up as well. It's always good to have a really detailed science chat with someone I appreciate.
Thank you for listening to this week's episode of the Gladden Longevity Podcast. If you would like more information on what we've discussed or other topics, please reference the show notes or go to GladdenLongevityPodcast.com. You can also find us on Instagram, Facebook, and Twitter by searching Gladden Longevity. If you've enjoyed this podcast, please subscribe to get future episodes delivered to you, and share our podcast or this episode with someone in your life that you may find benefit. Thank you for listening. We'll be back next week with another exciting episode. The Gladden Longevity Podcast is provided for informational purposes only. It does not constitute medical advice. This content is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of a physician or other qualified health provider with any questions you may have regarding a medical condition. The use of any information and materials linked to this podcast is at the listener's own risk.